In this session, we will take a look at simplifying rational expressions, reducing. When we think about reducing, we think about canceling out common factors. For example, the fraction 12 over 18 is the same as the fraction 2 over 3 because 6 goes into 12 2 times and 6 goes into 18 3 times. That tells us that the fraction 2/3 is the same as the fraction 12 over 18. In other words, 2 out of 3 is the same as 12 out of 18. They have the same proportion. The property we are using when we make fractions equivalent to each other is indeed doing that. It's making fractions that have the same proportion. And the property says that if we start with 2 out of 3, and if I multiply the numerator by 6, I need to multiply the denominator by 6 as well. We are really multiplying by 1. And when we multiply a number by 1, we don't change its value. All we're doing here is changing the proportion. We end up with 12 out of 18 because 2 times 6 is 12, 3 times 6 is 18. We have the same proportion. Hence, the property says when you have a fraction a over b, this is the same as taking a times c over b times c, provided that number c does not equal 0. So as long as we multiply both numerator and denominator by the same thing, we end up with a true statement. We end up with a proportion that a over b is the same as ac over bc. Likewise, a over b is the same as a divided by c over b divided by c. And again, c does not equal 0. 12 over 18 is the same as 12 divided by 6 over 18 divided by 6. So we divided the top and bottom by the same number. When we make rational expressions equivalent, we are making them to have the same proportion. And those two properties will allow us to do that. Let's take a look at an example. If we have 4x squared y over 16xy squared, and the question says reduce. Now the goal is to ask ourselves, what common factors can we cancel out? Therefore, we can cancel out a common factor of 4x and a y. That gives you x in the numerator and 4y in the denominator. Let's take a look at another example. X plus 1 divided by x plus 3. Question says reduce the lowest terms. And now we might be tempted to look, I have an x on top, I have an x on the bottom. I might be tempted to cancel them out. But are they factored? This expression, x plus 1 over x plus 3, is already reduced. There's nothing we can do to it to make it have a simpler form. When we think about 4 plus 1 divided by 4 plus 3, it has the same form as x plus 1 over x plus 3. And when you add the terms in the numerator, you get 5. And in the denominator, 4 plus 3, we end up with 7. 4 plus 1 over 4 plus 3 is 5 over 7. And this is not the same as if we try to cancel out the 4's, do we write 1/3? Or if we cancel out the 4's and replace them with a 1, we get 2 on top and 4 on the bottom. 5 over 7 is not the same as 1/3, nor is it the same as 2 over 4. The reason is that you can only cancel something if you can factor it. Let's take a look at another example. X squared minus x minus 6, all divided by x squared minus 9. The first step would be to factor, and the second step would be to cancel common factors. That means that we want to factor the numerator, and remember when we factor a trinomial, we want to use the method that we learned in factoring quadratics. We ask ourselves, what are the factors of -6 that add together to give -1? And the answer is -6 is equal to -3 times +2. At the same time, -3 plus 2 makes that middle term -1. Remember, the pair of numbers had to do two things. Had to multiply together to give -6, at the same time add together to give that middle term -1. And so we have our factoring, x minus 3 times x plus 2. Now in the denominator, we only see two terms. And remember, when we only have two terms and we're asked to factor, then we are thinking special forms, or we're thinking greatest common factor. When we look at x squared minus 9, that's a special form. That's the difference of two squares. The difference of two squares will always factor as a plus b and a minus b. So in the denominator, we have x plus 3 and we have x minus 3. Step number 2 is to cancel out a common factor. Now we can see that we have a common factor on top, x minus 3, and a common factor on the bottom, x minus 3. And we end up with x plus 2 over x plus 3 as the solution to the problem in lowest terms. Remember, technically, when we cancel out a common factor, we're replacing it with a 1. And so we have 1 times x plus 2 on top and x plus 3 times 1 on the bottom.